Good afternoon, Emre. Also, hi everyone. How are you? Thank you so much. I am fine. Thank you. Today, we state, I think, some slides. This is the chemical compounds. Thank you so much. Yes, Emre, you can ask. I think we state here. I'm waiting your question, and also I cannot do anything, Emre. Please, you should say that to your advisor. I can't do anything. Okay? Which one? Which one lessons completed? Yes, here. Do you understand, Emre? I think you understand. We did here, I think, this slide, and then we did that example. I think we state the naming of chemical compounds. For example, where is it? Yes, here, I think. Do you remember naming compounds or organic and inorganic compounds? Here we are. Yes, let's start. If you don't say anything, let's start our lessons naming compounds, organic and inorganic compounds. Actually, I will teach you the inorganic compounds generally, because organic compounds and organic chemistry is also lessons. Only I will show you some organic compounds, and I will explain that. But here, this is important thing, the inorganic compounds. And inorganic compounds, generally, we will say that the between metal and non-metal, metal and non-metal, or two non-metal elements get together, and then we'll give you a compounds. This is the not only inorganic compounds but also molecular compounds and inorganic compounds, called generally or contains metals and non-metals, but the molecular compounds contains the only non-metals elements. Okay, don't forget that. And you know that the compounds formed by carbon and hydrogen, or hydrogen together with oxygen, nitrogen, and a few other elements, we call that, this is, what's that? This is the organic compounds. And the others except the carbon atoms, this is the inorganic compounds. And these organic compounds generally considered a special branch. This is the chemistry, organic chemistry, and it has its own set of nomenclature rules. There are some rules to name these organic compounds, and here compounds that don't fit this description are inorganic compounds. Here, this is the brown powder compounds, chemical compounds, and then yes, this is the brown, and this is the yellow powder chemical compounds. Here there is a lead and there is a oxygen, but this is the physical properties is different because the color is different, and some chemical for the chemical reaction their behavior is different, but there is only lead and oxygen get together and gives a compound. What are these? For example, the first, and this is brown compounds, is called lead. Yes, lead 4 oxide, and this is lead 2 oxide. Okay. Yes, there is a lead and there is a oxygen, but the proportion is different. Here 2 oxygen, but here only 1 oxygen we can call, and then the lead is the metal, and the lead is the also cation, we can call that. The metal charge is different because here the lead charge is the 4, but here the lead charge is the 2. Don't forget that, because some metal ions charge will changing, and then we can call that their charge. Okay, don't forget that. Here, names and formulas of inorganic compounds. This is very important. For example, to writing chemical reaction or to writing aqueous solution, the names and formulas of inorganic compounds very, very important. First of all, binary compounds or metals and non-metals. These compounds are consist metals and non-metals. Binary compounds are those formed between 2 elements. These are the metals and non-metals. If one of the elements is a metal and other non-metal, the binary compound is usually made up of ions, because the metals are cations and they have the positive charge, and the other one, the non-metals, and their charge is always negative, and we can call that this is the anions, ions. And it is the binary ionic compound. We can call that these are ionic compounds. If we have the metals and non-metals, these compounds called, what's that? This is the ionic compounds. Don't forget that. This is important because the ionic compounds naming and the molecular compounds naming is very different each other. Don't forget that. To name a binary compound or metal and a non-metal, write the unmodified name of the metal first of all. Okay. First of all, you will write the first metal name unmodified, and then write the name of the non-metal modified to end in iide. Okay, iide. This is important. For example, look at here. The name of this is the rules. Okay, these are the rules. First of all, the first element is always metal, and this metal's name is unmodified, and then the other one, this is the non-metal, and non-metal name write the modified to end in iide. Okay, here the iide. Here let's check here. The approach is illustrated below for the sodium, chlorine, magnesium, iode, and aluminium, and oxygen. For that, here sodium we have, this is the metal, you have to know that this is the metal, and also this metal has only one charge, and then we write here the name unmodified, this is the sodium, and then for the second element, you will change this element name, and then you will put the end of this element's name iode. Okay, this is the chloride, sodium chloride. And for example, magnesium you write unmodified, and then for iode, and this is the iodide. And for the aluminium, because the magnesium, sodium, and aluminium has only one charge, okay, only one charge. For example, sodium has the +1, and magnesium has the +2, and aluminium has the +3 charge. You have to know that. And you write here the aluminium, and then the second one, this is the oxide, aluminium oxide. There is a X here, actually here. Yes, this is the X, aluminium oxide. For example, check here, iron trichloride, we can call that, because you have to know that I will give you a table, and there are some anions and cations, and you have to know all of that cations and anions. Iron 2 chloride, and this is iron trichloride. Why? Because for example, for that iron chloride, because you have to know that the iron has not only one charge. That iron has two type charge. Okay, always two type charge. What are these? These are the 2, and the other one 3. Don't forget that. So if I want to understand these are different, that difference come from here, the iron here and here, that one. For example, check here, just a minute here. Yes, the iron metal, always the first elements will be metal, because we learn here the ionic compounds, and this is the chlorine. Okay, that's 2 come from that charge, the iron charge, and the iron what's that? This is write down here. There is no appear here the 1. Actually, there is a 1, and that 1 comes here from that charge. Okay, don't forget that, and be careful here. Generally, you complicate it here, and then you will do wrong thing, wrong name of the compounds, because be careful here. And you write here the iron. You know that this is the metal and this is the cation, and the cation always has the positive charge and 2. And then you know that the chlorine is the anions, and you know that you should know that this is the anion, and this has the negative charge, here the -1. So you can call that this iron 2 chloride. This is ferrous chloride. This is the different naming of iron chloride. If you can call that, this is the true one, and this is the true one. Okay, and the other one, this is the iron. Yes, that 3 comes from the charge of iron, and that's only one here come from the chlorine charge. Okay, so we can call that this is the iron 3 chloride. Iron 3 chloride. Okay, don't forget that. For example, check here. Here you know that always the oxygen charge will be -2, and this is the copper. The copper will be what's that? This is the +2, and yes, +2, and that 2 go to the right down to the oxygen, and that 2 go to the right down the copper, and you can write here the copper 2 and oxygen 2, but we always write here the simple one, okay, and you divide it to 2. This is the copper 2 oxide, or you can call it the cuprous oxide, and the other one the copper 1 oxide. Here copper 1 oxide, you know that here there is a 1, and this one comes from the copper charge, and that 2 comes from the oxygen charge. And you know here the oxygen -2, and the copper, you know that this is the metal, this is the cation, and +1, and this is copper 1 oxide. That's it. Is that clear? I think clear, because you know that from your high school and your high school exam. Maybe you forget, but here I think you remember. Is that right? This is there any question about that? I think you have no question, because I will ask you a question about that naming. Yes, here some simple ions, and you have to know all these ions, and lithium, sodium, potassium, like that, and you have to know the chromium ions has two charge, and this is what is that 2 type charge. This is 2 and 3, and the other iron, this is 2 and 3. Cobalt has the 2 type charge. This is 2 and 3, and copper 1, 2 charge, and mercury is the 1, 2. Tin and lead, actually tin and lead has 2 charge. Actually, why they didn't write anything about that? This is the +4, and this is the +4. Okay, the tin and lead have these charges, and the other negative ions. For example, for the negative ions, the hydrides, there is a Y here. Yes, hydride. This is all of these ions are anions, and anions has always the negative charge, don't forget that, and cations always the positive charge, and the cations generally or always we can call they are metals, and negative ions and the other one, the anions, always will be what's that? Non-metals. Don't forget that. Okay, non-metals, and they have they come together and they give ionic compounds. Yes, hydrides. This is the hydrogen, fluoride, chloride, bromide, iodide, oxide, sulfide, and nitrate ion has the negative charge, and nitrate ion has the 3 negative charge. Don't forget that. Yes, I will give some example about that. For example, barium oxide. Okay, barium oxide. Okay, first one. And second one, for example, calcium fluoride. Calcium fluoride. And then, for example, what's that? Cobalt 3 chloride. And then for mercury 1 oxide, and 5, for example, magnesium bromide. Please do that. Okay, you write the chat. Yes, Bihter, you are so fast. Barium oxide, calcium fluoride, cobalt 3 chloride. Emre, you agree? Mercury 1 oxide, and then magnesium bromide. All of that are true or not true? The others, do you agree, Bihter, or not agree? All of that true. Are you sure? What about the mercury 1 oxide? What about mercury 1 oxide? Let's do together. Mercury 1, you know that mercury 1, here the molecular compound has, because the mercury is the only the one liquid metal, because the others, all of the others except the mercury is the solids. Only the mercury has liquid metals. This is the 2 and plus 2, and here oxygen negative 2. This is, what is that? This is magnesium 1. Yes, magnesium 1. Here comes here, and then that one come to here. But here, yes, that's right. This is the 2, and yes, this is the 2, and these oxygen go, and then we have mercury 2 oxide. You write like that? Yes, that's right. Thank you so much, Bihter. And the others only agree. Yes, what about here? For example, sodium. I don't say anything about that. It's not sodium. Yes, this is the one. And then yes, and other. I think the bitter bitter doing all of these naming. What's that? Yes. Meryem, Osman, Emre, Bihter said for the one aluminium fluoride. Yes, that's right. Why? This is the aluminium trifluoride. You don't say anything. Aluminium trifluoride. Why? Don't say anything. All of you said aluminium fluoride. Why? This is the aluminium trifluoride or aluminium. Yes, aluminium trifluoride. Why? You don't say like that. And then I check. Bihter said copper 1 oxide. 4 lead 2 oxide. 4 lead 2 oxide. Abdulkadir. Abdulkadir, for the fifth question you said lead to 2 oxide, I think. Yes. Yes, this is the fifth I said. Yes, you said something. Yes, you're right. Okay, you're right. And then I will check because you will do some wrongs and you will see which is the wrong or which is the right one. Yes. Mariam, copper 1 oxide for the second. Yes. Moed, aluminium fluoride. And I ask you a question, why don't you say anything aluminium trifluoride? You said aluminium fluoride. Why? Suleiman, aluminium fluoride. And then copper 1 oxide. Yes, all you did the first and second question. It has only one state. Yes, Bihter, thank you, because the aluminium only one charge, okay? Has only one charge or one state we can call. Yes, and then Suleiman said aluminium fluoride, copper 1 oxide. Yes, the others, the third one, fourth one, and fifth one, please say something, but Bihter, you don't write anything because if you write all of these answers, the others, yes, that's right. This is I accept her. Okay, I know you know all of that naming. The others, let's do that. Suleiman, chromium trichloride, chromium trichloride. Yes, that's right. And then the fifth one. The fifth one. What's that? Yes, I am waiting. Only the Münir set. Abdulkadir Münir set for the for fifth question. Lead to oxide, Ahmed said, and the other. Yes, lead to oxide, you said. Yes, this is aluminium fluoride, you said. That's right. And this is the copper oxide, not copper oxide. This is copper 1 oxide. Don't forget that this one. And this is the barium sulfate. Yes, that's right. And chromium, you said chromium trichloride. Yes, that's right. And the fifth one. Peter, I know you know Okay, this is the 4 oxide, because if you write here lead 2 oxide, if you want to lead 2 oxide, lead, yes, if this lead is the 2 here, and the oxygen has the 2, and that will be lead 4 oxide. Yeah, I don't write, yes, that's right. But here, this is 4. I said here the lead has the positive 4. I said, maybe you here, this is the 4 and the oxygen, and the oxygen charge will come right down, and this will come right down to the oxygen, and you write Pb2 O4, and only we write the simple formula. Yes, this is the lead 4 oxide. Okay, don't forget that, and don't complicate this naming. Yes, that's right, Yusuf. And let's do other binary compounds of 2 nonmetals, and we can call these compounds molecular compounds. And if the 2 elements in a binary compound are both non-metals instead of a metal and non-metal, the compound is a molecular compound. Okay, these compounds are molecular compounds. The methods of naming these compounds is similar to that just discussed. For example, this is the, yes, hydrogen chloride. The hydrogen is not metal, but we write it, here the hydrogen chloride, and ID. This is this name, but there are some differences between the molecular compounds naming and inorganic compounds naming. In both the formula and the name, we write the element with the positive oxidation state first. This is the hydrogen, not right here the chloride first one. Okay, don't forget here. For example, here we have some example, and we did here barium oxide and calcium fluoride, iron 3 sulfate here. Iron 3, that means the iron has 3 positive charge. Okay, these are the example, and this is your homework. And homework is not the there's not any submit time, because this is only for you for study. Okay, because you asked me. And this is example. I think we did that. Sodium sulfate and aluminum fluoride. Is that clear for all of you? Is that clear, or explain again? But you can watch this example in the recordings, and we did our, yes, this is your homeworks also. And yes, this is the molecular compounds naming. We have some differences between the ionic compounds and molecular compounds naming. I said to you, some pairs of nonmetals form more than one binary molecular compounds, and we need to distinguish among them. Okay, don't forget that we have some prefixes. Okay, prefixes. For example, for the mono, 1, D, 2, and 3 3 is the 3, tetra is the 4, penta is the 5, hepta is the hexa is the 6, hepta is the 7, octa is 8, nona 9, deca 10, and so on. And for example, sulfide and oxide are non-metal ions, and we can call that this is the anions, and they come together and get the molecular compounds, and these molecular compounds naming is different than the ionic compounds. For example, like check here, this is the sulfur, and we have the oxygen here, the 2 oxygen, so we write here the D, sulfur dioxide, because we have only 2 oxide. Here we have 3 oxides. We write first of all the first element name. This is the sulfur, and sulfur 3 oxide. How many oxide? 3 oxide. Okay, sulfur 3 oxide. And then, for example, check here. For this example, for sulfur dioxide and sulfur trioxide, we don't write for the first elements in the beginning, not monosulfur dioxide, okay? But we have, let's look here, for the boron, we have 2 boron, so we have to write here the D boron, because we have the 2 boron, and bromide, how many bromide here? Tetra. So we write here tetrabromide, diboron, tetrabromide. Okay. For example, carbon monoxide. Yes, carbon monoxide. Not we write here monocarbon monoxide. Okay. We don't write if the first element only has one, we don't write this is the mono, only carbon monoxide, like sulfur trioxide. Yes, check that table. This is the naming binary molecular compounds. For example, boron trichloride, carbon tetrachloride, because we have chlorides, 4 chlorides, carbon monoxide, carbon dioxide, you know that, nitrogen monoxide, nitrogen dioxide, dinitrogen monoxide, dinitrogen trioxide, dinitrogen tetraoxide, dinitrogen pentoxide, like that. For example, this is the phosphorus pentachloride, or this is the sulfur hexafluoride. Okay, don't forget these binary molecular compounds naming. And finally, several substances have common names. For example, this is not the hydrogen monoxide, this is the water. And for the ammonia, we don't write this is the first one, the hydrogen, and then the nitrate one. We don't write this is the trihydrogen mononitrate. Always we write here the ammonia, because this is the spatial compounds of for the molecular compounds, and this is the systematic names we can call. Yes, binary acids. These binary acids are also important. For the naming binary acids, we usually use the prefix hydro. Generally, we call because of they are always in the aqueous solution. So we write here the hydro. Sorry, this is the hydro. Hydrofluoric acids. This is the hydrobromic acid, because this is always the ionic. This is all these compounds always in the aqueous solution. So we call that this is the hydro. chloric acid, or you can call that this is the hydrogen chloric acid. For example, hydroiodic acid and hydrosulfuric acid. A binary acid is a two element compounds of hydrogen and a nonmetal. There is a hydrogen will be, and then the other one the nonmetal. And if you put these hydrogen chloride in the water, the hydrogen ionizes into the hydrogen anions for the cations, and then the other one chlorine ions. It is a binary acid we can call it. The other, yes, the polyatomic ions are very important writing molecular compounds, and we have some rules, and some rules, these rules important. For the first one, polyatomic anions are more common and than polyatomic cations, because we have only generally we use the ammonium ion, okay, and I will give you table of these polyatomic anions. And the second one, very few polyatomic ions carry in the iod and in their names. For example, hydroxide, okay, and this is the for cyanide ion, okay, and the common endings, the iod and aid, and some names carry prefixes hypo or per, okay. Some polyatomic ions naming the prefixes has hypo and per. And the third one, an element common to many polyatomic anions is oxygen, and usually combination with another nonmetal such anions are called oxoanions, okay. There are lots of oxygen they have, and fourth one, certain nonmetals such as the chloride, nitrate, phosphor, and sulfur form a series of oxoions containing different numbers of oxygen atoms. Okay, or sometimes only one or two and three and four. They have lots of oxygen has. Their names are related to the oxidation states. The oxidation state here important, or non-metals atom to which the oxygen atom are bonded, ranging, for example, the lowest one hypo and the highest one is the per. Generally, the per has the 4 oxygen and hypo has only 1 oxygen. According to the following scheme here, increasing oxidation state of nonmetal, hypoiod we can call it, and this is the iod, aid, and per-aid. Okay, increasing number of oxygen atoms. Here the rules, that rules is important rule. And the fifth one, all the common oxyons for that here has their charge carry -1. Okay, don't forget. And the sixth one, sixth rules, some series of oxyons also contain various number of hydrogen atoms and are named accordingly. For example, that here hydrogen, phosphor, and this is the 4, and the hydrogen phosphate anion. Okay, hydrophosphate ion, and here we have not only one hydrogen. If we have 2 hydrogen, and we can call that the prefixes D, we can put the prefixes here, dihydrogen phosphate ion. Don't forget that rule. And this last one, the last rule is that the prefix Thio signifies that a sulfur atom has been substituted for an oxygen atom. The sulfate ion has a 1 sulfur and 4 oxygen atoms. Thiosulfate ion. Yes, that's right. But the thiosulfate ion has 2 sulfur and 3 oxygen atoms. Let's check that table. I think we have the table. Yes, that's right. This is the some common polyatomic ions. Yes, there's only one cation we have. This is the ammonium ion. Yes, this is the typical compounds, and this is the cation, polyatomic ion, and this is the chlorine. And the others, anions. What are they? These are important acetate ion, important acetic acids. You know that comes from this acetate ion, and then the carbonate ion here, the carbon and 3 oxygen, and this carbonate ion charge is only 2 state, and the hypochlorite. Yes, this is the hypo. Yes, there is only one oxygen has, so we can put these hypo prefixes, and then we can set hypochlorite. And if this increasing oxygen, don't forget that, and increasing the oxidation state here, this is the chloride for the chloride atoms, and this is the chlorite, and perchlorate ion. Per is the highest one. Remember that from the slides, last slide. This is the perchlorate. Per is the highest one, highest oxidation state, or highest oxygen has. Chromate is here, and dichromate here, cyanate, hydroxide, and nitrates and nitrate. Nitrate is the only 2 oxygen, but the nitrate has 3 oxygen. Oxalate ion, permanganate ion, phosphate here, phosphate ion, and hydrogen phosphate ion has only 1 hydrogen, and the hydrogen, 2 hydrogen ion for the phosphate ion. Sulfate, yes, SO3, and always the charge is 2, -2, and if the hydrogen comes beginning of the sulfate ion, hydrogen sulfate ion we can call it, or bisulfate ion we can call it. Sulfate ion here, there is only 1 more oxygen added, and then hydrogen sulfate ion we can say, and this thiosulfate ion, this is thio means actual thio means this is the sulfur ion here, and then the oxygen, 3 oxygen has for that thiosulfite ion. Yes, these are polyatomic ions and very important for naming some compounds. Yes, this is the oxo acids. Oxo acids, the majority of acids are ternary compounds, we can say. They always contain 3 different elements. Okay, 3 different elements. Check here the formula of acid: hydrogen, chloride, and oxygen. Chlorine and oxygen, 3 different type of elements. If one of the nonmetals is oxygen, the acid is called an oxoacid. Okay, oxoacid, and think oxoacids of combination of hydrogen ions and oxo ions, and for naming oxoacids is similar to that outlined for oxo ions, except that the ending aus generally instead of the it instead of 8. For example, check here for the chlorine, oxidation state only 1, and 3, 5 7 increasing of oxidation state, and this is the hypo, the lowest one. Remember that. And then this is the oxidation state is the highest one, and we have the much more oxygen has, and this is the perchloride. Yes, for example, nitrous acids. Yes, this is nitrous acid, and this is the nitric acid, and sulfurous acid, sulfuric acid we can call, and also we can put instead of the hydrogen, the sodium, the metals, we can call it here the sodium hypochlorite. Okay, sodium chloride. Only we put this metal name sodium. First of all, the beginning of these oxo acids started with this sodium hypochlorite, or sodium nitrates, and or sodium nitrate we can call it. For example, here, can you say that, for example, for A? Yes, say something about for the A. What is that? Yes, I am waiting your answers. What is that for the A? Actually, for the A, this is which type compounds for A, which types? This is the inorganic compounds, or this is, yes, this is inorganic compounds. All of these compounds are, yes, inorganic compounds, ionic compounds, or molecular compounds. And why? Yes, I am waiting. Are you there? Or not here? If you're not here, this is so bad. Yes, the first answer, cupric chloride. Cupric chloride, is that right? Eric, think again, please. Yes, for the A, Kübra. For the A, this is the ionic compounds, or this is the molecular compounds. Which one type? Which type of molecule? Yes, you said. I am waiting your answer, and you did some wrong, and this is good actually, because you will learn the true one. For example, Eric said cupric chloride, but think about that. This is ionic compounds or molecular compounds. Yes, Süleyman, thank you so much. This is ionic compounds. So you think the naming of ionic compounds, you did that. First of all, the metals you have and non-metals you have. And metals, check the metals. The metals has only one state, one charge, or has only two or more charge. More charge, you should know that. Okay, and for example, Habeb write copper D chloride. Why did you write here copper D? Why D? We use these prefixes mono, D, tri, hexa, hepta, tetra, penta. We did these prefixes for which one compounds? Which one compounds? We use that D, mono, D, tri, tetra, penta, hexa. We use, yes, say something. Actually, you learned before. Yes, molecular. So we have only non-metal elements we have only, but here the copper is the metal. So we cannot use these D-mono D3 tetrapentahexane for the naming ionic compounds. Okay. Yes, if you understand, no problem, Habib. This is copper. Yes, copper 2 chloride. Yes, that's right. 4-day copper 2 chloride. Yes. What about the B? What about the B? B is the ionic compounds or molecular compounds. First of all, you think that. Which type compounds is that? Okay, first of all, think that. And then you named. Yes, this is molecular compound because you know that the chloride and oxygen is the nonmetals, and these compounds is molecular compounds. Yes, and then you name that. Chloride dioxide molecular. Yes, what about the others? Think about that, Emre. You said chlor dioxide, you said chloride dioxide. First of all, you write the Turkish and then the English one, I think. But this is not true. Yes, Moyat, chlorine dioxide. What else? Chlorine dioxide. Yes, comes the true answer. Yes, that's right. This is the chlorine dioxide. What about the C one? What about the C? Yes, C has three type. C has three type or three different elements, and we can call that compounds. Yes, I understand, Emre. But not true. Okay, not true. Chlorine dioxide. Yes, what about the C? Actually, the C, oxoacids, because three type, the hydrogen, iodide, and oxygen you have. This is the oxoacids, and oxoacids called yes. I am waiting. Actually, this is a little difficult than the other, more difficult than the others. What is that? Actually, oxidation states, first of all, oxidation state you should find for the iodide. The oxidation state will be this is 2 and plus 1, and oxidation state will be, I think here, 7. Yes, oxidation 7 plus 7 oxidation state. And what is that? Purge, because the highest one we will use the highest one, naming purge. Yes, Moya, thank you so much. Periodic acid. Yes, that's right. Yes, the other one, the last one, D, for D. D is, what's that? This is ionic compounds or molecular compound. Yes, I'm waiting. I hope you don't check from the Google. Moyat, be honest, okay? You write the Google for the periodic acid, or you know that? Yes, you say something? Okay, Moet. Okay. You don't know? For D. You learn here. Yes, for D. Please say something for naming of these D chemical compounds. Calcium phosphate. Dun dun, Bihter. That's not right. Be careful. For phosphate, will not won't be hydrogen. There is any hydrogen. Monocalcium phosphate. Eric, please be careful about molecular compound and ionic compound. Okay, you complicated here. If you want to mono use, that will be that should be molecular compound. But here the calcium we have, and calcium is the cation, and the other that polyatomic is the anion. This is the cation, and these compounds, what's that? Ionic compounds. And for naming ionic compounds, we don't use the mono D3. Okay, Eric? Yes. Please study here. Yes, the others. What about the D? First of all, you have to write the unmodified name of calcium. Yes, this is the calcium, and this is that one, polyatomic anion. And polyatomic anion, this is the dihydrogen phosphate. Not only phosphate, Bihter. Dihydrogen phosphate. Yes, that's right, Eric. Calcium dihydrogen phosphate. Yes, that's right. Thank you so much. And yes, pass your homework. These are your homework. First of all, you have to think what type compound is that. Okay? First of all, think about that. If this is ionic compounds, so you name. This is a molecular compound, you can name. Yes. Yes, we have some hydrides, and hydrides compounds has some hydrogen molecules contains their building, and some complex substances you are certain to encounter are known as hydrides. In a hydride, each formula unit of the compounds has associated with it a certain number of water molecules. This does not mean that the compounds are wet, okay? That's not true, because this is the solid and not wet. And the water molecules are incorporated in the solid structure of the compound, okay? Incorporated in the solid structure of the compound, and formula like that. Yes, this is the cobalt 2 chlorides, hexahydride, we can call that. Okay, this is the important thing, and we did that one in the laboratory. Not the cobalt, but we did that the copper one. Yes, cobalt, you write here, this is the ionic compounds, and you know that the cobalt has 2 type charge, and here chlorine only one -1 charge, and here the cobalt 2 chloride. cobalt 2 chloride, hexahydride. You can call here that compounds. I think this is the copper chloride, and then while you heating that will be like that, this color, I think. Yes, names and formulas of organic compounds. A little, I will say something about that. Yes. Organic compounds has lots of compounds have in the nature, and the foods you eat are made up almost organic compounds, including not only energy producing fats and carbohydrates and muscle building proteins, but also trace compounds that impart color or odor and flavor to these foods. Almost all fuels, whether used to power automobiles or trucks or trains or airplanes, are a mixture of organic compounds of a type called hydrocarbons. Okay, hydrocarbons always has the carbon and hydrogen and other elements, but always will be carbon. Most of drugs has the organic compounds, plastics, and the multiply of organic compounds is so vast that the organic chemistry exists as a distinctive field of chemistry, and the organic chemistry arises because in the laboratory we get some products, and always they will be organic compounds, and investigated. Carbon atoms can form chains and rings, and the nature of the chemical bonds between the carbon atoms can vary. And you know that the simplest hydrocarbon contains one carbon atom and 4 hydrogen atoms, and we can call that this the methane. And methane is the alkane one. Hydrocarbons and carbons between their only one single bonds, and that means this is the alkanes. Okay, this is the simplest alkane, yes, methane, followed by the ethane, the C2H6, then propane, and fourth member of the series butane. Here butane has only 4 carbon atoms. Just a minute. Yes, if we have the 4 carbon atom, we can call this is the butane. And hydrocarbon molecules with one or more double bonds between carbon atoms, these are the alkenes we can call. Let's check here the last one. For example, methane. This is the structural here. Compounds, and this is the ethane. Ethane has 2 carbon atoms, and always one carbon atoms will bonded always 4 bonds here. For example, 1, 2, 3, 4. For that one, 1, 2, 3, 4. Okay. For the propane, all of these carbon atoms has 4 bonds. Don't forget that. For ethane, for example, this is the alkane. Check here. For the first carbon atom, 1, 2, 3, and 4 carbon atoms. and for the second one, this similar thing. And for the benzene here, benzene has like that structure, and this is the Bose functional properties here, like that. These are the, what's that, organic compounds. And organic compounds, I don't explain all of these because this is the organic chemistry we have, but we are gonna do the general chemistry, so this is the branch of chemistry, okay? Only you know that explanation. Yes, that's it for this week. Next week we did the other subject. This is the, I think, chemical reaction we did. We will do. Okay. Is there any question for that? When will we have the lab session? Will you come to the lab? Nada? No, okay. After I will do experiments in the laboratory, I will upload it here, all of these videos, okay? I think beginning of the May. Okay. Thank you so much. Thank you so much. See you next week. Thank you.